Helio is a real airplane. Fast, efficient, and amazingly versatile. This is an STOL landing at 30 miles an hour. STOL, also called STOL, stand for short takeoff and landing. Short means requiring less than 100 yards or the length of a football field for either landing or takeoff. Please note that the Helio is an uncomplicated airplane with conventional all-metal structure, simple to operate and easy to maintain. The large flaps double its wing lift height. The horizontal tail provides good control over the unusually wide speed range. The large vertical tail contributes to exceptional stability. The automatic slat on the leading edge of the wing, a British invention, prevents stalling. It is the simplest foolproof method ever devised for boundary layer control, a practical necessity for safe flight at low speeds. The interceptor device on the top of the wing solves the most difficult problem in short field operations, that is, adequate lateral control for slow speed landings in turbulent air. A normal takeoff in about 200 feet, full load and no wind, with a climbing turn at slow speed is completely safe. It is often the safest way to climb out of a confined area. The airplane is climbing to a specified 500-foot departure altitude, spiraling up within a closely controlled 100-yard circle before departing on a standard helicopter flight pattern. Ability to turn safely immediately after takeoff is often necessary to avoid high obstructions near small fields. Flying at 30 miles per hour, safe control is provided by the leading edge slats on the wing. With these slats, there is no risk of stalling or losing control. As the airplane slows down, the angle of airflow over the wing increases, and the air pressure automatically pulls the slats open. It requires no pilot attention and is proven completely trouble-free in service. With the slats and flaps retracted, Courier is cruising here at a high speed of approximately 160 miles an hour. The next three scenes from an official FAA test film record the airplane's incredible control and stability at very low speeds under turbulent wind conditions. The surface wind was recorded at 18 miles per hour with heavy gusts to over 25 miles per hour. In normal operations, when the surface wind goes much above 20 miles per hour, the flaps are partially retracted. With flaps full up, landings can be made safely in winds exceeding 60 miles per hour. To demonstrate the ease of control under extreme turbulence, these FAA tests included multiple landings and takeoffs with full flaps at minimum speeds, the airplane sometimes ascending and descending vertically. While the turbulence conditions here are extreme, the airplane's ability to provide this degree of completely safe control is the key to practical STOL operation. Next, the airplane is deliberately banked and turned near the ground to demonstrate the unusual controllability, and then it descends vertically in a high gusty wind, demonstrating again its exceptional stability. Next, the airplane is shown in a more normal STOL landing with no headwind. Then, during the subsequent takeoff in the opposite direction, you will note that there is an approximate 10 to 12 knot crosswind indicated by the dust blowing at right angles to the landing and takeoff path. This operation at the Polaroid factory in Massachusetts, together with the next 4 sites you will see, are typically available off-airport locations. These were all selected within a few miles of each other along the congested Route 128 section of suburban Boston. A much larger number of plant-side, home, and farm locations within this small, congested area were used for other off-airport landings during the 2 afternoons when these pictures were taken, but were deleted here for brevity. You will note now that the airplane will take off in the opposite direction from its landing. The dust blowing sideways shows the 90-degree crosswind. This takeoff with full load is made without benefit of any headwind. It is a perfectly normal, safe type of STOL takeoff. Next, the airplane is landing at another plant. The field length inside the fence is 600 feet, with about 400 feet of landing area available after crossing the small pond. With an approximate 10-mile headwind, you will note that the landing roll is proportionately shorter. Loading access is made easy through the left front door and right rear door. The front and rear doors are offset to attain maximum cabin structural strength. With special crash-resistant seats stressed to 15 Gs and with resilient steel tube structure around the entire cabin, the airplane can strike obstructions in flight and in fact has done so a number of times without injury to occupants. With several hundred Helios now operating in rough areas throughout the world, there have been numerous collisions with ground obstructions in low-altitude flights, but the FAA reports no fatalities recorded in any certificated production models. On the takeoff here, high obstructions are located close to the fence, directly in line with the takeoff path, approximately 500 feet from the starting point. The airplane, therefore, will turn approximately 90 degrees immediately after leaving the ground and then climb out parallel to the line of obstructions, never crossing the fence line until it has attained an altitude of about 75 feet. Next, an impromptu landing is made on a typical small New England farm field, approximately 900 feet in length, surrounded by high trees and telephone wires. Many Courier owners are accustomed to selecting fields of this size from the air without ground inspection. The ground here is rough and frozen hard. You will note that the airplane dips into a small gully just after landing. The extraordinarily rugged landing gear on this airplane, with the two main wheels being placed forward almost up to the normal nose wheel position of a tricycle gear, permits the Helio to land in mud, snow, or on hard surface with the brakes locked and without risk of nosing over. Since the time the first predecessor STOL helioplane started its test flying in 1949, this type of airplane has been developed and service tested under rough operating conditions throughout remote parts of the world. It now can take continuous abuse, far worse than you've seen here, and require very little maintenance. Next, the airplane is landing on a school football field. This same unusual short field performance of the Helio single-engine L-28 type has now also been incorporated into the new twin-engine six-place Helio U-5 model, combining this same rugged short-field capability with even greater load, range, and speed. The new twin-engine model takes off just as the single does here and provides, in addition, multi-engine reliability for long over-water and night instrument flights. The twin-engine version cruises at over 180 miles per hour with fixed landing gear and over 200 miles per hour with retractable landing gear. Next, the airplane is shown returning at the end of the day, landing on another rough, unprepared field adjacent to the owner's home. Significantly, these scenes were filmed during one weekend in 1954 using Helio's first production airplane, a 260 horsepower four-place model. This airplane was even then the result of a 6-year development program directed by Professor Koppen at MIT. 4 different experimental Helio models have already been built and tested before the 1954 Courier configuration was developed. Helio models have varied in size from the original 85 horsepower two-place experimental helioplane first flown in 1949 up to the recent 6-place twin-engine U-5 model. Much larger and faster models are projected with the same design features and with the same short field performance. Since 1954, the additional years of service testing have led to today's rugged high-performance 295 horsepower L-28. This airplane is now serving in Southeast Asia, where the free world's encounter with present-day guerrilla tactics revealed a need for the durability and simplicity, as well as for the range and speed of STOL-type airplanes for remote area operations. The STOL type of airplane is a logical companion to the helicopter. It supplements the helicopter's invaluable vertical takeoff capability for shorter distance work. However, where distance, speed, and economy are important, The new STOL types are now extending the practical range of efficient air delivery from big airports up to the actual ground terminal point, where only a few